Still in section 2.2 in the learner guide, let's look at number 2A. And now we're looking at problems that involve fractions. So we're solving equations still. So we know that as we solve an equation, we're expected to have a solution. And on number 2A, we have a fraction with a denominator of 3. So we've learned in this section that to clear out any fractions, we could multiply both sides of the equation by the least common denominator of the fractions. In this case, it would only be a 3. So we're going to multiply both sides of the equation by 3. When we do that, 3 times, and we can kind of move over here for a second, 3 times 2x over 3 is like 3 over 1 times that fraction. And notice what happens with the 3's is that they will cancel. So I'm left with 2x minus 3 times negative 5 would be that 15, so negative 15 equals 21. Now we're going to add 15 to both sides of the equation. So we get 2x is equal to 36, and then divide both sides by 2, which gives me x is equal to 18. So the solution to that problem is 18. Okay, now let's look at 2B, an application problem. And in this application problem, we have a mathematical model, so that just means basically a formula describing W as weight in pounds that lies within the healthy weight range for a person whose height is h inches over 5 feet. So h is inches over 5 feet. Use the formula to find a healthy weight for a person whose height is 5'6". So that means, and they've already told us here, h would be 6 because that's the number of inches over 5 feet. Okay, so we'll do the same formula that was given, W over 2 minus 3 times 6 equals 53. Now, we do want to clear the fractions out, but let's go ahead and simplify this 3 times 6 first. So W over 2 minus 18 is 53. Now, to clear out the fractions, let's multiply both sides of the equation by 2, which is the least common denominator. So we cancel out 2 times W over 2. So 2 times W over 2, the 2's would cancel, and I'm left with W. Now do 2 times negative 18, which would be a negative 36. And then 53 times 2 is 106. To get W by itself, let's add 36 to both sides. So W would be 142. So remember that that was weight in pounds. That would describe the weight in pounds that lies within the healthy weight range for a person. Okay. Now there's one more, well, there are a couple more. Let's keep going in the learning guide. And these are going to deal with equations that have solutions that aren't just one number. Everything we've done so far has been one constant is a solution. Okay, but look what happens here. When I simplify both sides, first of all, I'd have the 3x minus 7 equals 3 times x, and then 3 times 1. And then when I try to combine the variables, notice what happens. If I subtract 3x from both sides, the x's go away on both sides, leaving me with negative 7 plus equals 3. Now this is a false statement. When your variables vanish and you're left with a false statement, then the solution to the problem is that there is no solution. Okay, so you could write that as a 0 with a line through it. You could say the words that there is no solution, or you could have brackets that are empty. Okay, and what that means is absolutely no number could fill in for x and make that happen, make that work. And you can see why in that second step, if I plug the same number in both sides, Well, the three x's are the same, but because there's a -7 and a +3, you'd never get the same answer on both sides. Okay, if you go on to the second one, we have a different type of outcome. Simplify both sides, so I'm going to multiply, distributing the 2, so 2 times x plus 2 times 4, which is 8. Now let's combine like terms. 4x minus 2x is 2x. 5 plus 3 is 8. Now this time I have exactly the same terms on both sides. So if I were to subtract 2x here, they go away. I'm left with 8 equals 8, which is a true statement. Okay, and even if I subtracted 8 from both sides, I get 0 equals 0, which is still a true statement. So in this case, when the variables go away and I'm left with a true statement, we get that the solution is all real numbers. And the way that you would write that in this section is in a set builder notation. It's the set of all x's such that x is a real number. And that just means any number I plug in for x, and you can test a couple, will give me will make the equation work.